Our report is universalization of the method of predicting quality level of software based on the requirements. I am Tatiana Govorushenko. I represent Khmelnytsky National University, Ukraine. One moment. Software quality is the degree to which software meets the needs of the user when used in certain conditions by ISO 25 and 10 from 2023. Software quality according to the ISO 25 and 10 standard is determined on the basis of quality attributes defined in the ISO 25 and 23 standard. All quality attributes are already included in software requirements, so it is possible to assess and predict the quality level of software based on the requirements. The studied methods and tools for assessing and prediction quality of software have great potential for solving various problems and can be used in different contexts. But such methods and tools don't provide the prediction of the software quality level based on the quantitative value of quality, don't provide the calculation of quantitative value of quality based on the quality characteristics, and don't provide the calculation of quantitative values of quality characteristics. Thus, at this point in time, the methods and tools for assessing and predicting software quality are imperfect at the initial stages of software development, and assessing and prediction the quality level of software, the initial stages of development, is an actual task. The purpose of the study is to provide an assessment of the existing set of requirements from the standpoint of the predicted level of quality of the software that is planned to be implemented according to the set of requirements. Standard ISO 25 and 10 by 2011 regulates the dependence of software quality on 8 quality characteristics. New standard 25 and 10 by 2023 regulates the dependence of software quality on 9 quality characteristics. Of course, the number of characteristics may continue to change in subsequent versions of the standard. So the synthesis task is to develop a universal method for predicting and assessing quality level of software based on the values of quality attributes. And the analysis task is to obtain the predicted quality level of software. On this slide, you can see conceptual model of the process of assessing and predicting the quality level of software based on quality attributes. Such a conceptual model is an abstract model that defines the properties of elements and their cause and effect relationships, is based on an artificial neural network that processes the values of quality attributes extracted automatically from software requirements, and takes into account not only the values but also the mutual influence of attributes when quantifying software quality characteristics. We chosen the simplest and most studied architecture, multi-layer perceptron. The N has 4 layers, input layer of M neurons. This is values of M quality attributes from ISO 25 and 23. 2 hidden layers approximating and correcting, and output layer of N neurons. This is values of N software quality characteristics according to ISO standard in the range from 0 till 1. Universalized method of predicting and assessing quality level of software consists of the next steps. First step is implementation, training, and testing of the four-layer N of the multi-layer perceptron type. Second step is pre-processing of the software requirement specification by structuring it, and automatic analysis of requirement to find M quality attributes, and selection of values of M quality attributes from the requirements. Third step is processing of M quality attributes values by the developed M and prediction of M quality characteristics values in the range from 0 till 1, where 0 is the minimum value and 1 is the maximum best value. Fourth step of our method is geometric interpretation of the values of M quality characteristics in the form of M GON, formed by the values of M characteristics plotted on each the M semi-axis, and the angle between the semi-axis is 360 divided by M degrees. This semi-axis you can see on the slide. Next step is checking the acceptability of compensation for quality characteristics by determining where the n-gon is convex. None of its internal angles should exceed 180 degrees. If the compensation of quality characteristic is unacceptable, then further steps of the method are not performed, and such requirements are rejected or returned to developer for revision. Next step is calculation of the combined indicator of the predicted software quality as the area of the constructed n-gon by the formulas which you can see on the slide. Next step is calculation of the maximum value of the combined indicator of the predicted software quality by the formula which you can see on the slide, and the decision making by the rules if combined indicator is in area from in certain intervals, then the future software is predicted to have low level or average level or high level of quality by the rule which you can see on this slide. The input data for the developed method are software requirements. The output data is the predicted level of software quality. The advantages of the developed method are the ability to predict the quality of software under development based on existing requirements, the ability to compare sets of software requirements and make a reasonable choice of a set of requirements for the further implementation, the ability to reject unsuccessful sets of requirements, which saves the project budget and time resources, and independence from the programming language in which future software will be developed. The limitation of our method is the need for software requirement specification and its orientation to software quality determination by standards ISO 25M10 and ISO 25M43. On the slide, you can see an example of application of a universalized method of predicting and assessing quality level of software. According to the first step of the developed method, a four-layer artificial neural network of the multi-layer perceptron type was implemented, trained, tested, which has an input layer of 130H neurons approximating and correcting hidden layers, and an output layer of 9 neurons according to ISO 25 and 10 by 2023. For convenience, the 130H input neurons were divided into 3 sets of 46 neurons each. Now, 5 specification of software requirements developed by IT firms in Khmelnytsky were preprocessed by structuring, by automatic analysis of requirements, and select the values of 130H quality attributes from each specification. Next, the developed and processed the values of 138 quality attributes and predicted the values of 9 quality characteristics. You can see on the slide, and quality characteristics is numerated 1, 2, 3, 4, 5, 6, and etc. Now we can see a geometric interpretation of the values of 9 quality characteristics was constructed in the form of a 9-gon with an angle between the semi-axis of 40 degrees for the 5 analyzed requirement specifications, for 5 requirement specifications. And in accordance with the fifth step of the developed method, the acceptability of compensation for software quality characteristics was checked by determining where each 9-gon is convex. It is obvious that the 9-gons for the specifications of requirements 1, 2, 3, and 4 are convex, and the 9-gon for the specification of requirements 5 are not convex, so further steps of the method were not performed for the set of requirements. The requirements 5 were rejected. We calculated the maximum value of the combined indicator of the predicted software quality. Its value you can see on the slide. Then the combined indicators of the predicted software quality for requirements 1, 2, 3, 4 were calculated, and the predicted quality levels of software were determined. And the future software implemented according to requirements 3 will predictably have a high level of quality, and it is recommended to choose these requirements for further implementation. Conclusions. The article develops a universalized method for predicting and assessing quality level of software. The advantages of the developed method are the ability to predict the quality of software under the development based on existing requirements, the ability to compare sets of software requirements, the ability to reject unsuccessful set of requirements, which saves the project budget and time resources, and therefore reduces the likelihood of the project failing into the category of failed or challenged projects. Independence from the programming language in which future software will be developed, and the limitation of the developed method is the need for software requirement specification and its orientation to software quality determination by standards ISO 25 and 10, ISO 25 and 23. The direction of the author's future research will be the implementation of the universalized method of predicting and assessing the quality level in the form of a web-based software system, which will be available online 24/7. Thanks for your attention. Questions, please. Dear colleagues, questions, please. No questions. Thank you, dear colleagues. And we have one presentation is forecasting of acute upper respiratory tract infections based on LSTM model by Mykola Butkevich, Tatiana Chumachenko, and Dmitro Chumachenko. Who is speaker? Is speaker present? No speaker. This was our last presentation for today, and let's summarize the program of our section S3.3, Processing, Recognition and Prediction, included 5 presentations, but only 4 presentations were presented, and I will inform organizers of conference about this fact. I want to thank all the participants of our conference, of our section. Without you and your papers, without your presentations, the conference and the section simply would not have happened. Thank you so much. Now we will have a break for lunch, after which at 2 p.m. I invite everyone to the roundtable Digital Twins and Dark Artificial Intelligence by Dr. Andrzej Różyński. And see you soon. Thank you all.
Thank you
for your attention.